Hi everyone, and welcome to a review of how to find the domain of an expression or function. So let's take a look at some things to watch for when we're trying to determine the domain. Many functions have a domain of all real numbers, but if you see a radical in the expression, you want to make sure to check to see if it has an even index. That means it's like a square root or a fourth root or a sixth root. You can't have negative radicands, negative numbers inside of those. So just like with the square root of a negative number, you will get unreal answers. Like the square root of -4 is 2i or negative 2i. So these are not real answers, so you would want to exclude the negative numbers in this domain. You can, however, do the square root of 0. Now, for rational functions, functions where you have an x in the denominator, you want to make sure to find the zeros of those denominators and say that x cannot be those numbers because you cannot divide by 0. So those are the two places that you tend to find limitations in your domain. They aren't the only two, but they're the two most common ones. Let's take a look at some examples now. In our example, we're asked to find the domain of the following expressions. So these are all the values that x can take on in this expression that will still be defined. So notice this is just a regular polynomial. I'm allowed to square any number I want. It can be a negative number, it can be a positive number, it can be fractions, it can be decimals. I can square anything I want and multiply by 2. And I'm also allowed to multiply any number I want by 3. So basically, x can be any number that is real. So that's going to be my answer. Domain is all real numbers for this one. This is going to be true for any polynomial function. So anytime you have a polynomial, domain is going to be all real numbers. Now, for the next expression I'm given, it's x over x squared minus 5x plus 6. Now, this top x can be any number. It can be a negative, it can be 0, and it can be a positive, it can be fractions, it can be decimals, but in the denominator, this expression is not allowed to equal 0. So what I'm going to do is factor it and find the zeros of that denominator, and that's what x cannot be. The factored form of that denominator is x minus 3 times x minus 2. And if you need help with factoring, I do recommend my videos about factoring a trinomial. And then to find these zeros, you would put a positive 3 here, and that would be a 0 for this part. A positive 2 would be a 0 for this part. So my domain is that x cannot be positive 3 and positive 2. Let's take a look at our last example. In this example, I have two expressions with x. In the numerator, I have the square root of x. Now remember, I'm not allowed to do the square root of a negative number. So for this part, I have to say that x has to be greater than or equal to 0. In the bottom of it, I notice that it's x minus 5. So I need the 0 of this denominator, which is 5. So x cannot be 5. Okay, so the denominator, we have x can't be 5. Notice what I did. There are two ways you can write that. You can write the inequality and that x can't be 5, or you can write it in interval notation. Notice in my intervals, I'm including 0 all the way up to 5, but 5 is not included. And I'm uniting it with the set from 5 to positive infinity. Again, that 5 is not included. So those are the two ways I can write that domain. So I hope this was helpful. Let me know if you have any questions.